Let's say you came across this video as a Jambite for the first time. They said 0.16 gram of methane. When burnt rises the temperature of 100 gram of water by 40 degrees Celsius, what is the heat of combustion of methane if the heat capacity of water is given? One thing you need to know as far as this type of equation is concerned is that this specific heat capacity is a constant. I repeat, the specific heat capacity is a constant. In that case, this is how or the type of formula that you can easily use in a short time because of the time frame given to you for your examination. So we said we have heat of combustion equal the mass of water, then the mass of water over mass bonds multiplied by molar mass. So looking at what you have at the numerator here, the M stands for mass of water, while this C is specific heat capacity of water, which I made mention earlier that it is constant. Why this temperature? In case this change in temperature is this minus, so in case we are given to temperature, this theta 2, the highest temperature, theta 1, the lowest temperature. In that case, if you are given to temperature, meaning they are going to subtract the highest from the lowest. But now looking at what we have on the whiteboard, we are only given one temperature. So guys, what is the mass of water? Let's go back to the question again. It said is 0.1 gram of methane. The mass bonds is, so we said mass bonds is 0.16 gram, comma. The molar mass of CH4, which is methane. So carbon is 12 plus 1 times 4. So we said we have 16 gram per mole. Now guys, what is the mass of water for this? Mass of water is going to be, okay, methane when burnt rises the temperature of 100 gram of water. It is stated clearly here, so we have 100 gram. The specific heat capacity is this. While the temperature is given to be what? 40. In that case, we said heat of combustion. There's one thing you need to know as far as this type of equation is concerned is that the unit of this is the same thing as that of heat of formation, which is kilojoule per mole. So guys, the mass of water is 100 multiplied by our C, the specific heat capacity of water, 4.2. The temperature is what? 40 multiplied by 40 divided by the mass bond is 0.16 multiplied by 16 gram per mole. We have 1 here is gram. We have this, we cancel this. So the gram for this, we cancel the gram for this. In that case, we said, let's multiply what we have at the numerator, then we divide. So we said 100 multiplied by 4.2 multiplied by 40 multiplied by 16. We have this. So in that is divided by 0.16 divided by 0.16. So we have this. So 1,680,000. Now, for us to have our kilojoule, we are going to divide this. I repeat, for us to have our kilojoule, we are going to divide our answer with the value of kilojoule. So that will give us, so we are left with this. Kilojoule per mole. Initially, we are having joule per mole. But for us to have kilojoule per mole, which is the final answer, and the unit of what we are asked to calculate for. You are going to divide your answer irrespective of what you have. You are going to divide it with 1000 so we can have these smaller units. Now, so let's take a look at the option respectively. Option A, no. Option B, no. Option C, no. Option D is the correct answer.